So that's how you ended up getting the value of x, which is part A. All right, to find Q1 and Q3 respectively, you got to put all that in your calculator into stat edit and then do, L1 and then, L1, and then you can do your frequencies, or you could just write it all into L1, however you'd like to do it. But then you got to do stat calc one variable stat. Okay, and then you end up with Q1 being 5 and Q3 being 6.5. All right, so your calculator will give you that information. And then determine whether the value of x is an outlier. Well, x will either have to be less than quartile 1 minus 1.5 times the interquartile range. So whatever that would give me, which I do not have a calculator in front of me. I should find one. Let me do that on my computer while let's see. I mean, I could probably do that by hand, I guess. I didn't. So 6.5 minus 5 is 1.5, obviously. So 1.5 times 1.5. And then is 2.25, which I knew. And then just subtracted from 5. So x would basically have to be less than 2.75. And nothing in our data is less than 2.75. But to find about the bigger part, you'd have to do x must be greater than 6.5 plus 1.5 times the interquartile range, which is 1.5. So then you would have 2.25 plus 6.5, which I don't know why I'm using a calculator, but just to give you the exact number, you would get 8.75. So if x is greater than 8.75 in our data, then there is an outlier. And we had 9.5. So yes, this is an outlier. And that's where that came in. Because 9.5 is a shoe size in our data set that we got in part 1. So that is definitely an outlier. All right, question 3. Miss Alcock wants to find out the proportion of households in the United States, right there, proportion of households in the United States who have a pet. For her investigation, she decides to ask colleagues at work, which is located on the outskirts of a large city where their family owns a pet. Yes, I realize this had many parts to it, but I didn't want you confusing the sample and the population, which are two very different things. So the population of Miss Alcock's investigation, it says in the very first, wants to find out the proportion of households in the United States. So the population is all households in the U.S. It says at the very beginning that this is what I want to find out. Is this number 3? I was just seeing if this is number 3. Okay, so that is part A. And then part B, what is the sampling? Well, I'm sampling the people at work. So that's just convenience because I see these people every day and it's right here. So I didn't want you to get too confused with that. Most of you figured that out. But then my colleagues at work are the sample. The population is all U.S. households. Okay? All right, number 4 was the one that, yes, I messed up to begin with and now looks right. But anyway, you had the table. It said the mean was 2. I think most of you got this after I gave you that. Is the data discrete or continuous? This data is discrete. All right, because it is a finite number in which these kids are using the internet. So it is discrete. It's not going to change. Either you use the internet or you don't. State whether the data... Oh, we just did that. Okay, clearly. I'm killing it here today. All right, find the value of K. All right, so in order to find the value of K, you just had to take your data and divide by that would all be 88 plus k equals 2. And yes, again, that's the frequency. So you got to remember these numbers on top are coming from 20 times 0 plus 24 times 1 plus 2 times 30 plus 3k plus 4 times 10 plus 5 times 5 times 3 plus 6 times 1. That's where all this top part is coming from, okay? So similar to the shoe one, you have to count for the frequency. So you go ahead and do your math, and you get 145 plus 3k equals 2 times 88 plus k. And you do that out, and you end up with k equaling 31. All right? And this is actually systematic sampling. And most of you got that. Right? Because you looked at the different number of classes and we're taking groups and finding out the number. So systematic sampling. All right? Because, therefore, decided to put all the students in alphabetical order and pick every 10th student. So that's actually a condition and a group, and that is what defines this. Okay, number 5. I should not make these videos when I'm tired. All right, the marks achieved by 8 students on the test are as follows. We have 8, 4, 7, 6, 10, 9, 7, 3, it doesn't even matter. The teacher describes to increase the marks by 2. What is the new standard deviation? Well, if you put that list in your calculator, stat edit L1, why do I keep writing I's? You get the standard deviation, and that standard deviation will be whatever it is, which I think happened to be, somewhere I had that, 2.2. And that's what the standard deviation is originally, and that standard deviation will stay the same. The mean, median, and mode will change, but this will stay the same. Okay? So that does not change. That about sums up the solutions. If you have any further questions for me, feel free to reach out, but I did want you to have access to these. All right, bye.